13, we're going to talk about a couple different things. So the first thing is sketching the graph of a derivative if you're given an original function, and sketching the velocity and other rates of, or not sketching, but finding velocity and other rates of change. All right, so we're going to talk about sketching a derivative. So we know that a derivative is just the slope of the graph, right? So when I talk about f prime of x, it's the slope of f of x at a certain x value. Basically what you're going to do, the easiest way to sketch the derivative is to first find the places where you have horizontal tangents. So if you remember, horizontal tangents are where your slope is equal to 0. In other words, it usually happens at maximums or minimums. Occasionally it will happen, you know, oops, I don't know what I just did there. Occasionally it will happen like at something like y equals x cubed, right, where it tapers off to a horizontal tangent and then goes back up. So things like that. All right, you could also look for critical points where your derivative is undefined, corners and cusps, and so on. Okay, so the first thing we're going to start with are the horizontal tangents. So we have right here, here. And you guys see one more? Yeah, it's kind of like an x cubed function. It's right here. Okay, so those are the horizontal tangents. So if I was trying to find a numerical number for y prime would be equal to what there? Y prime equals 0, right? It's a horizontal tangent. So y prime equals 0. So when I'm graphing the derivative, what I'm graphing is all of those numbers. I'm graphing all of the y values as numbers. So I'm graphing y equals 0 at 3, y equals 0 at -1, y equals 0, and y equals 0. So I'm crossing the x-axis in those locations for f prime. Okay. Now I'm going to go ahead and draw something down here which might help us. I'm going to draw a little number line, -3, -1, 2, and 4. These are locations where we had a horizontal tangent, so where the slope was 0. All right, and then I want to talk about whether the slope is positive or negative in each of those intervals. Okay, so from here to here, so from -∞ to -3, what's the slope of f of x? Is it positive or negative? Is it going down or up? Down. It's going down, so the slope is negative. Does that make sense? So basically, I could find what those values are, and in your book, you guys had to. Like on one of your homework problems from last week, you guys had to kind of estimate the slope, and you had to count, well, I think the rise is this, and the run is a certain amount, and you had to estimate what those numbers are. I'm not asking you to estimate those numbers at this point. I'm just asking, are those numbers positive or negative numbers? Okay. As you can see, as you're drawing in the slopes of the vertical or the tangents, it is tapering off to 0. Do you guys see it's really steep? Like, look at my hand. Steep, steep. Not so steep, not so steep, not so steep, and it's tapering off to 0. Does that make sense? So it's big y values to small y values. Okay, so then between -3 and -1, is the slope positive or negative? It's positive, right? So from here to here, we had a positive slope, right? And then from -1 to 2, it's negative again. And then it's negative once again, right, from 2 to 4. And then it was positive from 4 to infinity. Does that make sense? All right. So what we're graphing is we're saying we want a graph, and maybe if I separate these, you guys can see it a little bit better. And then I'll draw on top of the other one. I want a graph where my y values are negative, and then they hit 0, and then they're positive, and then they hit 0, and then they're negative until we get to 2, hit 0, and then it goes back negative, and then positive after 4, okay? So here's what your graph of your derivative looks like. It's negative values, positive values until -1, negative, it bounces at 2, right, because it goes back negative. It's negative again, and then it's positive. Does that make sense? So you have a kind of like multiplicity there. Okay, so graphing it on top of the f of x function can be a little bit difficult. Like, students usually do not like this when I do it. They're like, what? So here's what we have. So I draw on the horizontal ones first, the horizontal tangents. So that's where y prime is equal to 0. And then I say, okay, the slope here was negative. It's down. So that means I'm going to be below the axis. And then my slope is positive, so I'm above the axis for my y prime. And then my slope is negative, so I'm below. I bounce below, and then I'm up again. So see, that's the same thing as what I drew below, but it's on top of the other one. Okay, I see confused stares. All right, the other class is like, wait, I don't get this because the slope is negative, right? You just said that the slope was negative here, and then you drew it going up here. Okay, it's not the same thing. What I'm saying is the slope of f of x is negative. So when I draw f prime of x, I have negative values for y. Does that make sense? We're talking about the y values for f prime, not the slope for f prime. All right, so let's do it again. So this one. So I'm not going to do as many steps on this one. We'll see if we can get it. So I look for my horizontal tangents first. So my horizontal tangents happen like between -2 and -3, somewhere around there. At 0, at 2, and then somewhere around 3.5, right? Do you guys see those? That's where I have maximums or minimums. So y prime equals 0. Okay, and now I think in each of those intervals, do I have a positive slope or a negative slope? So I start out with a positive slope. So when I graph the slope, I'm graphing positive numbers. So I'm above the axis, so I'm up here. And then I go, the graph of f of x goes down, right? It's decreasing. So the slope is negative, so I'm going to have y values for the slope is negative. All right, and then I'm positive, and then I'm negative, and then I'm positive again. Does that make sense? Do you see what I did there? And it's frustrating at first. It's like, wait, what? So one thing to notice is that our original function was probably something that was x to the 5th. If you look at the number of zeros it has, it actually has 5 zeros, counting multiplicity. Do you guys see those zeros? 1, 2, 3, 4, and 5, right? 3/4 it bounces in multiplicity. So it's an x to the 5th function most likely. Notice how its derivative is a w function. That's x to the 4th. Okay, does that make sense when you think about taking a derivative? If I had like y equals x cubed, when I take the derivative, what does it become? 3x squared, right? It's 1 degree less. Okay, every time you take a derivative, you're 1 degree less. Okay, so that's one way you can kind of check to see what you're doing. You can kind of think about the degree. Okay, so enough with graphing. We can talk more about that later. Let's move on. Okay, so how many of you guys have taken physics or in physics right now? So yeah, not quite half of you. Okay, do not be scared if you have not been in physics before. It's kind of interesting. If you take physics before, then calculus could be easier. But if you don't take physics before, when you get to physics, you're like, wow, this is easy. So it doesn't matter what class you take first. When you take the other one, you're going to be like, oh, I like totally get this. All right, so if you've had physics before, you've probably talked about this. If you haven't, it's fine. I'll start from the very beginning. Okay, so in physics, you learn that a particle can travel a certain distance from its starting point. This is called the displacement function. Okay, the easiest way to think about distance and displacement, and we'll talk about this a lot throughout the year, is if I tell my cross-country runners, Audrey, and I say, Audrey, go run 3 miles out and then come 3 miles back. How much did you move from your starting position? 0. You moved 0. That is the displacement. Does it make sense? Seems weird because she's like, I did a lot of work and I'm sweating really hard because I really went, what distance? 6 miles. Okay, so displacement adds up positives and negatives, and you could get a result of 0, you could get the result of a negative, or so on, okay? But distance just takes whatever numbers you have and takes the absolute value of them and adds them. So like 3 miles plus the absolute value of -3 miles coming back gives you 6. Okay, so that's distance and displacement. So the first thing we're going to start with is displacement. Okay, this is often called the position function. It's telling you where you're located. And the units are often meters, feet, miles, things like that. Okay, if you take the derivative of something, you're taking a rate of change. So when you take a derivative, what you're doing is like feet per second, meters per second, miles per hour. Does that make sense? So if I take the derivative of the position function or displacement function, I get velocity. Okay, does that make sense? So I have displacement or position, and then I have the velocity. But if I have meters per second, and I take its derivative, so if I take the derivative of the velocity function, I get meters per second, which we write, you can think of it this way, divided by seconds, meters per second times 1/2. What do we get? Meters per second squared. Do you know what that is? Acceleration, right. So if you start with the position function or displacement function, and you take the derivative, you get velocity. Take the derivative again, you get acceleration. Okay, that's how they're all related to each other. All right, so if you start with the displacement function s of t, s prime of t is the velocity function, and s double prime of t is the acceleration. So that's v of t, and this one is a of t. Okay, so you'll be asked that a lot on the AP test. We're going to start off with some very basic examples today. In first period, they were like, is this as easy as it is? No. Like, this is what, month 1 of school? It's going to get a lot harder for the AP test, so we're starting out with the basics. And then if you ever see something on the AP test that asks for the speed, you always want to use that the speed is the absolute value of the velocity. Okay, so basically, if I go in reverse, I could be going in reverse 20 miles per hour, right? And my velocity would be negative 20 miles per hour. It's telling me what direction I'm going, but the speed would just be 20 miles per hour. Does it make sense? The speed is always a positive number. Velocity tells you the direction. So speed is only the magnitude. Velocity is like a vector. It's like direction and magnitude. Okay, so number one. So it says the equation of motion or position of a particle is this. Okay, it's always something random on the AP test. It's never something that makes sense based on physics. Okay, so where S is in the meter is in meters and T is in seconds. Find the velocity and acceleration as functions of T. So our velocity is just going to be the derivative of our position function. So when we take the derivative, we get 3t squared minus 3. And our acceleration is going to be the derivative of the velocity function, right? S double prime of t. So it's going to be 6t. All right, find the acceleration after 2 seconds. So it's saying find a of 2. So all I'm doing is 6 times 2, so I get 12. Oftentimes on the AP test, you get not bonus points, but you get points for just, I know, wouldn't that be awesome? You get points for just writing the units, okay? So even if you got the wrong answer, but you at least knew that this was going to be meters per second squared, you would get a point just for the meters per second squared. All right, then acceleration when the velocity is 0. So this is a two-part problem. So we first need to find the time when the velocity is equal to 0. So if you just write v of t equals 0, you often get a point just for writing that. But if you make a mistake and you're like, oh, I'm not going to write v of t equals 0, but then you say, 6t equals 0. What was the mistake there? 6t is the acceleration, right? It's not the velocity. Right, you wouldn't get a point because you don't have the wrong setup. Does that make sense? So always write it in the simplest form first. So we're going to have 3t squared minus 3 is equal to 0. And we solve, so we add the 3 over, divide by 3. So we get t squared equals 1. So t equals plus or minus 1. Which one makes sense? Time 1, just positive 1, right? Can't go back in time. Although that would be cool. All right, then you would never get any bonus points. I would always go back in time and steal them. All right, so the next one. So we're trying to find the acceleration when your velocity is equal to 0. So this is the time when your velocity is equal to 0, so now you plug in. So we have the acceleration after 1 second is going to be 6 times 1. So we get 6 meters per second squared. That's our answer. So it's a two-part question. All right, number 2. So the velocity of a unicycle is shown below. So if you guys have ever seen Maddie Hoover's older brother ride a unicycle, has anybody ever seen that? Probably one of the most amazing things I've ever seen in my life. Because not only does he ride it on a unicycle, which I think is impressive anyway, but he can juggle fire while riding a unicycle. Isn't that the coolest thing? It happened at one of our morning meetings. I'm promising, I'm not lying about this. It was really cool. I was a little bit scared that the curtains were going to go on fire, but he did it. I was very impressed. That's what the talent show used to be like, right? All right, so anyways, the velocity of a unicycle shown below. Use the graph to answer the questions. So this is a graph of the velocity. Always make sure you identify what your graph is of. It could be acceleration, it could be position, it could be anything. Okay, so know what you have graphed. So it says at what time or times is the unicycle stopped? So when it's stopped, that means your velocity is equal to 0. Okay, so write that down. Sometimes you'll get a point just for that. So velocity is equal to 0 at 3 different locations. Right there, and right there. So at t equals 0, 30, and 55 minutes. When is the unicycle going backwards? So what are we trying to find now? V of t is negative, right? Less than 0, right? If we're going backwards. So when we're less than 0, it's going to be between here and here. So it's going to be where t is between 30 and 50. So I'm going to say between t equals 30 and t equals 55 minutes, right? I almost messed it up. I did it earlier too. Now, some people in the other class said it was only from 30 to 40. Why is it not just from 30 to 40? All right, what's happening from 30 to 40? We're going backwards and we're going pretty fast. We're getting faster, right? And then what happens from 40 to 50 or 55? It's going forward. We're still going backwards, right? We're just slowly slowing down. Okay, we're slowing to the stop. Okay. What is the acceleration at 30 minutes? So at 30 minutes, how do we find acceleration when we have the velocity graph? How is it related? Yeah, it's a slope. So the acceleration is the slope of the velocity. So we want to know if we can find the slope at 30 right here. Can we find the slope of that line? And a lot of people think it's just -1 actually. They think it goes down 1, right 1. What is wrong with saying that it's -1? It's not -1. Nick, what do you think? It's not a 1-by-1 grid, and that will often happen, right? It's not. So you have to kind of count. You have to say, oh, well, if I am trying to find the slope of this line right at 30, I'm going to go down, it looks like 20 units, and I go over only 5 units. So your slope, so your acceleration at time 30 is going to be -20 over 5. And then -20 was in meters per minute, and the 5 was in minutes. So what's your final answer going to be? -4 what? Yeah, meters per minute squared. That's why it's an acceleration. Exactly. All right, so the next one. So it says, what is the speed at 35 minutes? So at 35, we're right here. Remember speed, when you ask about speed, it's the absolute value of the velocity. So we want to find the velocity at 35 minutes. So our velocity is just what's graphed, right? The velocity would be -20. So the speed then is 20. So it's 20 meters per minute. And then the last thing, when is the acceleration the greatest? So what's that saying? When is the slope the steepest, basically, right? Acceleration is the slope. When is the slope the biggest? So I only have 2 possibilities. There's only 2 places where it's positive, here and here. So we're going to compare them. Which one looks steeper? The first one, right? So if you look at your slope, this one goes up 60 and over 10. So its slope is 6. This one goes up 40 and over 15. So if you do 40 over 15, is that bigger than 6? No. So m equals 6 is what we want. So the acceleration is the greatest on the interval 0 to 10. So you can just write it like that. Or you could say between time 0 and 10 minutes. Does that make sense? You have a lot of graphs on the AP test. So a lot of things like that where you have to figure out what's going on. All right, next step. Okay, so when you're driving a car, the speed or velocity is constantly changing. So even if you have your cruise control on, some of you guys have probably noticed this as you're learning how to drive and so on. Have you used cruise control? It's very handy, especially in Carmel. You get a lot of tickets in Carmel. Be careful. Don't say I didn't warn you. All right, so you have the cruise control on. And if you go up a hill, do you ever feel like your car like struggling to kind of get back up to that speed? Right, it's not always going to be that constant. Right. So there's definitely like maybe you have it set for 65 miles per hour and you go 63.2 or 66.7 as you're going down a hill. So we don't know, right? So there's a definite velocity at every single moment. We call this the instantaneous velocity. Okay. So if your AP test asks for the average velocity, right, that means the average rate of change. Okay, average rate of change of what? What do you think? Rate of change of what? Yeah, of like your position, right? So it would be like S of B minus S of A. Oops, it's hard for me not to do that. S of A all over B minus A. Okay, so depending on your position function, you're just finding it between 2 endpoints. So you're saying, oh, on average, I went between this and this. The instantaneous velocity is saying at an exact time. So at a certain moment, exactly how fast were you going? So in other words, it's the derivative of the position function at a particular point. So this is always happening on the AP test. It will always say average rate of change of F, or average rate of change of the position, or average velocity, or whatever. That's when you're using this, F of B minus F of A. You're always on some kind of interval, all over B minus A. But if you say, what is the derivative of the position function? What is the velocity at time 3? What is the blah, blah, blah at this time? It's saying at that specific moment, okay? That's the instantaneous rate of change. So it's the derivative. All right, so to kind of show you what I'm talking about, on the AP test, you're going to have tables and you'll have functions. So maybe you just have a table and you can't take the derivative because we don't know what the original function was, right? Then you're probably asking, what is the average velocity on this interval, right? And it's probably going to give you different things. So that's kind of how this one is. So it says, if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet t seconds later is given by y equals 40t minus 16t squared. Find the average velocity, so the average rate of change, for the time period beginning when t equals 2 and lasting 0.5 seconds. So if I start at time 2 and I last for 0.5 seconds, I'm finding between 2 and 2.5. So I'm going to do y of 2.5 minus y of 2 all over 2.5 minus 2. And the easiest thing to do would be to put this in for your table, because you're going to have to find several values, right? So I'd get your calculator out, and we'll go ahead and do 40x minus 16x squared for y1. So I'm going to try this along with me. Maybe I'll put it up here so you can see it. Oops. Okay. Here's math. Take this on. Okay, so when you go to second table, we want to put in different values. So we want to find between 2.5 and 2 seconds. So go ahead and put in 2.5 into your table and put in 2. So when you plug in 2.5, you actually get 0. Okay, so its position at that time is 0, meaning it's hit the ground. So we have 0 and we have 16. So we're going to have 0 minus 16 all over 0.5. So we get negative 32. And it's in feet per second. I'll just do seconds. Yes. All right, so then if I want between 2 and 2.1 seconds, right, I have y of 2.1 minus y of 2 all over 2.1 minus 2. So I do the same thing. So when I find 2.1, I'll do it on this other calculator. I get 13.44. So 13.44 minus 16 all over 0.5. No, not 0.5, 0.1. So I get negative 25.6. Did you guys get that? Feet per second. All right, and then I really want you to be careful on the 2.01. So on your calculator, so I'm putting in 2.01, because when I look at it, it looks like it's going to be 15.758. And this is going to be very, very important when you're using the table. You want to get as many digits as possible. You don't want to have a rounding error in the middle of your problem. So what we're going to do is we're going to go up and over so that we highlight that number. And when you do that, do you see along the bottom how I have 15.7584? I can see all of the digits now. Okay, always make sure that you do that. So we're going to have y of 2.01 minus y of 2 all over 2.01 minus 2. So we got 15 point, what was it? Oh, let me go back. 7584. Yeah, 7584. Minus 16 all over 0.01. So what did you guys get when you did that? Negative 24.16. Is that right? Feet per second. All right, so what do we think it's getting closer and closer to? Yeah, probably around negative 24, right? So I would guess that if I was finding the instantaneous velocity at time 2, I'm probably going to get negative 24 or somewhere around there. If I'm getting 512, I've done something wrong, right? We just show that it's getting closer and closer to a certain value. So the instantaneous velocity, so if I find that, what I'm doing is I'm actually finding y prime. I'm finding the derivative. So I'm going to have 40 minus 32t. And I'm going to plug in time 2. So I get 40 minus 32 times 2. So 40 minus 64, which is indeed negative 24. So negative 24 feet per second. But like I said, it's important that you know both ways because maybe you're given a table or maybe you're given a function. We don't know. Maybe you're given the graph. And it says, when is the velocity equal to 30 feet per second? So write that down. Say v of t equals 30. Right? Because like I said, sometimes you'll get a point for just doing that. But if you make a mistake and you get in a hurry and you're like, oh, I'm setting 40t minus 16t squared equal to 30. Right? That's a mistake. That's not the velocity function. That's the position function. Do you guys understand? And you'd be surprised at how many times that happens on the test. And then you don't get points, like little tiny points that you could have easily gotten. All right, so what we want to do is v of t equals 30. So v of t was 40 minus 32t. And we're solving it out. So we get negative 32t equals negative 10. So t equals 10 over 32. So 5 over 16. Which you could leave as that in seconds. Or you could say, or 0.3125 seconds. Acceptable answers on the AP would be 0.3125 because that's an exact answer. 5 over 16 is an exact answer. Or 0.313 if you round to 3 decimals, or 0.312 if you truncate. So all 4 are accepted. All right. Okay, any questions on that? Pretty straightforward. Yeah, it's not too bad. All right, so let's talk about econ. How many of you guys are in econ right now? Fun, fun, fun. Not very many of you, I'm surprised. Yeah. All right, so in econ, whenever you use the word marginal, it's used to indicate a rate. So the marginal cost is just the cost per item at a specific moment in time, okay? Marginal profit is the derivative of the profit function, so it's the profit per item at that certain point in time. So it says, nowadays, new efficient machines allow the cost of a product to not be constant. So I'm going to give an example about necklaces. My aunt sells necklaces. She goes around to different, like, fairs and festivals around Indiana and around the U.S., really, and sells necklaces, okay? So she's selling them, and she makes them by hand, and it takes her, I don't know, 3 or 4 hours to make each necklace, right? She could buy a machine that could help her make necklaces, that helps her to string the beads on faster, and she can sell even more, okay? Let's say that she spends 20 bucks for a machine, and instead of taking her 4 hours, it now takes her only an hour for each one. Should she buy the machine? Probably, right? She's probably selling the necklaces for enough money where making more of them faster, right? Making more of them would be good because she can sell enough of them. Does that make sense? But if the machine costs $10,000 and it changes her amount that she's making from, like, you know, takes her 4 hours to 3 hours, probably not worth it, right? It wouldn't be worth it. Does that make sense? Right. Don't buy it. It's too expensive. She would lose out on a lot of money. So it depends on what your payout is. And this happens all of the time in real life. Have you ever been to a factory? Right? Factories are run in 2 different ways. Sometimes there's assembly lines with people working the assembly line. So with cars, there's people putting the cars together. And then sometimes there are machines that do it. Literally look like robots that are putting things together. You should go to a factory. It's pretty interesting. So it's kind of like, do you spend all this money on this robot, or do you spend the money on the people? It's probably cheaper in the end for the people than this giant robot, but whatever. All right, so it says, besides marginal cost, you could see many other terms about a cost function in economics. You might talk about the average cost. This is exactly what you think it is. Average cost is taking your total amount of money spent and dividing by the number of items made or bought or whatever. So the average cost is going to be, we write it as C of X bar. We read it as C bar. Do you like that, C bar? And what it is taking the total cost and dividing by the number of items. Okay, so if everything cost $1,000 and you only made 10 of them, then the average cost would be $100 per item, right? All right, so let's think about the first time you ever made money. So lemonade stand. Did you guys all do lemonade stands when you were little? They're like every weekend in my neighborhood, and they charge so much money. It's like $1 or $1.50 per glass. It used to be like 10 cents back in my day, inflation. It's ridiculous. But I always support the little lemonade stands because the kids get so excited when I stop my car. They're like, oh, yay. So I always buy. All right, so suppose you are a little kid and you go to the store and you buy 6 of those awesome Country Time lemonade containers for $1.50 each. Okay, how much money are you spending? Too much.
$9.
$9, right? 6 times $1.50, you spent $9. I like Country Time. All right, so with each container, you're able to make a lot of lemonade. So you can make 60 little glasses of lemonade, right? 60 cups of lemonade. And then you're selling them for 50 cents each, right? So if you sell all of the lemonade, you are out there all day, you are just, man, sweating, getting a sunburn, you're selling all this lemonade, and you sell it all. How much money is in your collection jar at the end of the day? What's your revenue? Nope, more. Because you have 6 of those containers. $180. That is a lot of money. That's a lot of lemonade that you're selling. All right, so that's 180. Have you seen them at Kroger on like the National Lemonade Day? There's like kids at Kroger selling lemonade. So they make a lot of money. All right, anyway. However, this is not your profit because if you're a good little kid, you always pay your mom back for what she spent on that lemonade. Or if you went to the store and bought it yourself, right? So you really spent $9 on that lemonade, so how much is your profit really? 171. Okay, so do you understand the different words that we use? Revenue. Revenue is the amount that's in the jar at the end of the day. Profit is taking that amount and subtracting out how much you spent on it. Okay, so profit is always revenue minus cost. That's a very important equation in econ and in math. All right, so let's do a couple problems with this. So let's just talk about the basics just in terms of X with this one, and then we'll do one with actual numbers. All right, so number 1 says the cost of producing X units of a certain item is C of X equals 1/4 X squared plus 3X plus 67. The price at which each item will be sold is P of X equals 1/5 times 45 minus X. Suppose we sell all X items. Okay, so find the marginal cost. So whenever you see the marginal word, what that means is the derivative. So we're finding the derivative of the cost function. So C prime. So we look at our cost function and we take its derivative. So we have C prime of X equals, are you guys experts now? 1/2 X plus 3. That's it. So if I said, find the marginal cost of producing the 100th item, it would be $53. Because you'd plug in 100 and you'd say, oh, for the 100th item, it would be this much money. All right, find the average cost. So the average cost is going to be, that's the C bar thing. And what we do is we take the total cost and we divide by the number of items that we have. So our total cost is 1/4 X squared plus 3X plus 67, and we divide by the number of items X. So we end up getting 1/4 X plus 3 plus 67 over X. All right, the next one, find the revenue. So if I'm finding the revenue, I need to think about the lemonade stand. If I sold each one for 50 cents and I sold 100 cups of lemonade, how much money did I make? 50 cents, 100 of them, $50. Does that make sense? Okay, so what we're doing is we're taking the price for each item and we're multiplying by the number of items we sold. So revenue is going to be price per item times the number sold. So in our case, the price per item was given to us. It was P of X, not profit, but little p of X. And then the number sold was X. We sold everything. So we're going to have 1/5 times 45 minus X, that's our P of X, times X. So I'll go ahead and simplify because I need to take the derivative on the next step. So I'm going to do 1/5 times 45 is 9, and then times X. So 9X minus 1/5 X squared. So that's the revenue. What is the marginal revenue? So marginal, again, when you see that, you're taking the derivative of the revenue function. So you're going to say R prime of X equals, let me take the derivative of this one. So we have 9 minus 2/5 X. See how I got that? Take the derivative. profit is revenue minus cost. Our revenue function was the 9x minus 1/5 x squared. We had it in part C. The cost function was our original, 1/4 x squared plus 3x plus 67. So we simplify. We have negative 1/5 minus a 1/4, so we get negative 9/20 x squared. We have 9x minus 3x and plus 6x. Then we have negative 67. So that's our profit. So last but not least, if I find the marginal profit, I take its derivative. So marginal profit is negative 18/20, so that reduces to negative 9/10 x plus 6. And that's it. So I could ask you for certain numbers for each of those. So I could say, find the marginal profit of producing, 10 items, right? And you could find that. Does that make sense? If you only produce 10 items, it would be negative. It kind of makes sense that you'd get a negative. Not producing very much. Okay. So next one. So last one. So it says, suppose that C of x is equal to 0.02 x squared plus 2x plus 4,000 is the cost in dollars for a company to produce x units of a certain product. So it says, compute the marginal cost at x equals 100 and compare this to the actual cost. So this is something we have not talked about yet, so I want to make sure that you know, because I asked you this in the homework. So marginal cost at x equals 100. Marginal means derivative. So we're trying to find the derivative of the cost function. So if I take the derivative of the cost function, I end up getting 0.04x plus 2. So when I talk about the marginal cost, I'm saying, what is the cost per item when you have produced 100 items? Okay, so for that 100th item, what's basically the approximate cost around there? Okay, so I'm going to have C prime of 100. So I'm going to have 0.04 times 100 plus 2. So 0.04 times 100 is 4. 4 plus 2 is 6. So it's $6 for that 100th item, around there. All right, now compare this to the actual cost of producing the 100th unit. Okay? In order to find the actual cost, we need to do the total cost of producing 100 items, but we need to subtract out the total cost of producing what? Any ideas? If I only want just the 100th item. Yeah? What'd you say? 99. That's correct. Good. Think about that. I only want to know the cost of producing the 100th item. So finding C of 100 isn't finding that for me. It's finding the total cost of producing the first 100 items. Right? If I want only the 99, or only the 100th, I need to subtract out that first 99. Okay, now this is not so fun because you do 0.02 times 100 squared plus 2 times 100 plus 4,000, right? That finds the cost of producing the first 100 items. And then you subtract out the cost of producing 99 items. Right, and you can do this. You can put it all in your calculator. You can even use your table to help you. Right, what it ends up being, because I did it in the other classes, it's 598. Should those be close to each other? They actually should, yeah. They should be very, very close. And what ends up being easier to find is the marginal cost. Do you see why we use the marginal cost? It's much easier. Think about when the Industrial Revolution happened a long time ago, actually later than the Industrial, we had to wait for calculus, I guess. But when calculus was first created, right, that's how they're computing how much it's costing for each item as they use efficient machines and so on to produce things. Does that make sense? They're using the marginal cost. They're not putting this all in and finding this on paper, right, without a calculator. That would be a mess. It takes forever. Can we do it now? Yeah, we have Excel. Microsoft Excel makes things very easy in the business world. So we can do it now, but it's much faster to use the marginal. Okay, it's always 1 degree less. It's easier. Okay, so that's why we use the marginal cost. And then we're going to skip B because I made a mistake on that. It's actually got an asymptote, so we're going to skip that. All right. You pass out your homework.